Hello everyone. So now after purification, now we will do qualitative analysis of organic compound, means detection of organic compound. So first here we are doing detection of carbon and hydrogen. So carbon and hydrogen we will react with cupric oxide. So it will form CO2 and H2O. This CO2 further we will react with slacked lime. So it will form milky precipitate. Hence it is proved that in that element carbon is there. And hydrogen, which is H2O, reacting with CuSO4 anhydrous colorless. So it will form blue color CuSO4.5H2O. So detection of carbon hydrogen is done. Now coming to detection of other elements. So mainly we have to study detection of nitrogen, sulfur, halogen and phosphorus. And this is done by Lassine test. So first what we will do, we will create their sodium fusion extract. Means this all those substances like nitrogen, sulfur, halogen and phosphorus, we will react with sodium. After heating that substance, we will dissolve in water, and that filtered solution is called sodium fusion extract. So you can see organic compound fused means heated with dry sodium in fusion tube, and fused mass after extraction with water is boiled and filtered. That filtered is called sodium fusion extract. So like here you can see nitrogen NaCN sodium fusion extract, sulfur Na2S sodium sulfide and sodium halide. So these are the three, like that nitrogen, sulfur and halogens fusion we created, sodium fusion extract. So first we are doing, after creating sodium fusion extract, now we are doing detection of nitrogen. So that sodium fusion extract NaCN, we will react with FeSO4. So double displacement reaction will happen and it will form FeCN2 and Na2SO4. And this FeCN2 further we will react with NaCN. So it will form sodium hexacyanoferrate Na4FeCN2, FeCN6. And after that, this FeSO4 which we took, that FeSO4 further we will react with concentrated H2SO4. So you know that concentrated H2SO4 is mild oxidizing agent and dilute H2SO4 is not oxidizing agent. So that concentrated H2SO4, iron plus 2 will go to its plus 3 form, ferric sulfate. And with ferric sulfate, this sodium fusion extract we will react. That sodium fusion extract, this we will react. And after reacting, we will form here Fe4 FeCN6, that is ferriferrocyanide, Persian blue color. If you will do crisscross, so this -4 this side, +3 this side. So this is ferri, and here -4 and cyanide is -6. So this iron is +2. So ferro. So ferriferrocyanide, or this is only called Persian blue color. So detection of nitrogen done. So detection of nitrogen, what we are doing? After sodium fusion extract NaCN reacting with FeSO4, double displacement reaction happening. So it is forming FeCN2, further reacting with NaCN. So it is forming Na4FeCN6, sodium hexacyanoferrate, and that again reacting with iron +3. So it is forming ferriferrocyanide, Persian blue color. So detection of nitrogen is done. But this is not possible, that this Lassine test, in that nitrogen, those compounds which is azo group, means nitrogen bond, like here you can see hydrogen. So hydrogen do not give Lassine test. Why? Because in Lassine test, in that nitrogen, you have seen that sodium fusion extract we created, that is NaCN. So here NaCN cannot be created, nitrogen having 2 hydrogen bond and along with 1 nitrogen bond. So here that it does not contains carbon, so it cannot, hence cyanide cannot be formed. Why diazonium salt do not show positive Lassine test? So diazonium salts are unstable and it loses N2. So you know that N2 is very good Liping group, and in diazonium, even it is aryl diazonium, on heating it is very unstable, so N2 gas will release. So no sodium fusion can be formed, NaCN. So further reaction not possible. And if amount of nitrogen is less, so in Persian blue, that blue color will be somewhat green. Coming to next, detection of sulfur. So in detection of sulfur, that we will react with lead acetate, and either we will react with Na2FeCN5NO. So if we are reacting with lead acetate, Na2S sodium fusion extract, so it will form black precipitate PBS. And if we are reacting with Na2CN5NO, then it will form sodium nitropuroside Na4FeCN5NOS. Na4FeCN5NOS, and its color is violet. So by this two we can detect detection of sulfur. If nitrogen and sulfur both are present, then what we will do? Then we will create its sodium fusion extract, which is sodium thiocyanate NaSCN. And this NaSCN react with FeCl3. It will form bloody red compound FeSCN whole thrice. If sodium fusion extract, that this one NaSCN, if it is reacted with excess of sodium, so it decomposes, and then further it will form NaCN and Na2S. So NaCN already we discussed that detection of nitrogen, how to do that, nitropuroside, here that this one Persian blue color, not nitropuroside, ferricyanide, blue color. And for sulfur already we discussed, either PBS black precipitate with lead acetate, or with Na2FeCN5NO. So it will form violet colored compound. So in both way we can do. Either we can do this one together, bloody red compound, or we can pass excess of sodium. So it will form NaCN and Na2S. This both fusion we already studied. Now coming to halogens. So halogens, sodium fusion extract of that NaCl or either NaBr or NaI reacted with acidified nitric acid. So it will form, and then treated with silver nitrate solution. So here you can see sodium fusion extract is acidified with nitric acid, and then after treated with silver nitrate, so NaCl reacting with AgNO3, so you know that it will form AgCl white precipitate. Detection of chlorine is done. If this AgCl further reacted with ammonium hydroxide, so in ionic equilibrium we have studied that Ag plus compounds are soluble in ammonia NH3. So here this AgCl is soluble in NH4OH, and it will form one soluble complex, that is AgNH3 whole twice Cl. Similarly, here NaBr, that sodium fusion extract reacting with AgNO3, so it will form AgBr, and this will form yellowish precipitate. And NaI, sodium fusion extract reacting with AgNO3, it will form yellow precipitate. Detection of iodine is done. If nitrogen and sulfur both are present in that compound, then what will happen? That nitrogen also will react with AgNO3, sulfur also will react with AgNO3. Why? Because that nitrogen, if it is there, so nitrogen is in form of NaCN, and sulfur is in form of Na2S, sodium fusion extract. So that may react with AgNO3. So here you can see also present in compound, sodium fusion extract is boiled with concentrated nitric acid. So what we will do, that we will we will boil that one solution with concentrated nitric acid. So NaCN and Na2S that formed during the Lassine test, otherwise they will interfere with silver nitrate test. So here what? Actually that nitrogen and sulfur, those in that along with halogen, if it is present, then it will create hindrance in the test because it will react with AgNO3. So what we will do, we will boil with concentrated nitric acid, then NaCN and Na2S reacting with nitric acid, since nitric acid is oxidizing agent, so it will form NaNO3, and along with HCN gas it will evolve out. And similarly Na2S reacting with HNO3, so it will form again NaNO3, and H2S gas will be evolved out. So like that we can remove nitrogen and hydrogen while doing detection of halogens. If NaCN and Na2S are not decomposed, if NaCN and Na2S are not decomposed, then white and black precipitate, when it will react with AgNO3, it will form AgCN and Ag2S, white and black precipitate. Next, coming to test of phosphorus. So first we will create its sodium fusion extract. So reacting with Na2O2, that phosphorus, so it is forming Na3PO4 and Na2O. This Na3PO4 reacting with oxidizing agent HNO3, so it will further form H3PO4 and NaNO3. This H3PO4, where phosphorus is there, we are reacting with ammonium molybdenate, that NH4 whole twice MoO4, and along with HNO3. So it will form very important compound. Remember this formula, always they are asking that NH3 whole thrice PO4, 12 molybdenum, 12 MoO3, along with 21 NH4NO3 and H2. So this formula is very important. Ammonium phosphomolybdenate. So detection of phosphorus, what we are doing, that first phosphorus is reacting with Na2O2 forming Na3PO4, reacting with HNO3 forming H3PO4, H3PO4 reacting with ammonium molybdenate forming ammonium phosphomolybdenate. Last, detection of oxygen. So there is no direct method to detect oxygen. In organic compound, it is heated in dry test tube in nitrogen atmosphere. If water droplets are formed on the walls of the tube, indicate presence of nitrogen, presence of oxygen, and presence of oxygen can be known by testing functional group containing oxygen like alcohol, acetic acid, and so on and so forth. So here basically in conclusion, we studied that carbon and hydrogen, and then after nitrogen, then after sulfur, then after halogens, and last we discuss oxygen. So thank you very much. We'll meet again second topic, that is quantitative analysis of organic compound, that is estimation of organic compound. Thank you.